Here, I am going
It's a
to.
teeter-totter.
No, wait.
And it balances.
Yeah, it's certainly a work in progress. I like it though.
No, please share stream. Please share the stream. Come on.
He really does.
Yeah, it's funny. Unfortunately, the coder is going to mean it's not going to be able to do that anymore.
Yeah.
No, powered by our French. Oh, you're right. Yeah, our club runs on French.
Yep. And I'm just gonna play the theme. Since people are about to come in, our little theme song. So I'll just.
I still think it's hilarious that I did not know that we had
Because I keep forgetting to tell people that we do.
We just kind of put it in the background of like a little bit.
Yeah. Wait, what did you say? What you say? It's terrific. Yes. Our stream are terrific. Hello, streamers.
Hello, gamers.
Hello, gamers.
This is
Yeah, honestly, what I'm thinking is something on the side right here. I think I'm going to get part of it. Head in that direction. Have the facing the ball drilled out. Drill press. You can release the yeah. I already got the
I might say about a while for sure.
Yeah, so we're actually, I'm trying to work with the library up there in audience because they got a
Is there anyone in the chat?
at the moment, there's just one person.
Oh, okay.
Hello, one person.
Hello.
Hello. Nice to meet you, one person.
We're just gonna wait for a little bit, see if anyone else shows up, and then if no one else, then we'll get started.
Give this one person a show.
Yeah. Oh, totally. I don't know.
No pressure.
Well, we do have a demonstration. I don't know how that's gonna work out for that one person. For live demonstration.
They won't be able to see it.
Yeah.
They can bring the computer up to.
Unless if we have like a webcam to.
Is your webcam not on?
I mean, my webcam, but like a USB external webcam. Would you be willing to like throw from your laptop since this one's kind of. Okay. Hello. Welcome. Have a seat. With the fight. Hold on. We'll get to that in just a minute. Okay.
But you guys are all I'll just set this here for you.
Okay.
Should we set that bot? I guess I'm gonna bug in the bot.
Oh my god.
That'd be funny.
Well, wait a minute. I can't use this laptop to throw the image over there.
You can't?
I mean, I have to physically move the thing.
That's not a webcam, so you can just like have a webcam connected and just like turn it over. Or, oh, yeah. Like 30 to an hour.
Yeah. If you want to play or play
These
something
things are
online,
so tough.
and you want to play video games,
Shreds
trivia,
it, so now we're not actually gluing them.
it'll be on Discord.
Once you're tired, you just shoot up, you just throw away the wheel up as well.
What?
They
Rip.
really just.
They're leaving because they think the meeting's gonna be too long.
Yeah,
I was, those right there, I think together.
Okay.
I know.
We went through the text.
I know.
It's okay, it's late. People are trying.
Gearbox in that was $50 for 2
Realistically,
Are-
like
I don't think we're able to show the box from here,
Yeah.
like with that webcam.
Well, I mean, yeah, all I'm looking for here, I'll just move over there.
Other
Getting back to
Okay, cool. Thank you.
I don't know why, we have the biggest like.
Just let me know whenever you want to do that.
Yeah, yeah.
Like set up, 'cause currently I just need to.
Less than 3 years.
Okay, gotcha.
Or we just build a box.
We found a way to.
We don't have any we don't have any.
I want to use them, like,
Webcam.
is it really worth it?
I had to turn my laptop off.
Turn the box.
Yeah.
No, like move the box closer or to the table.
Yeah.
Since no one's, since there's not a lot of, there's not a big audience right now.
We're not terribly well armored.
Depends on what you want to do.
Let's go for about 10 more minutes and then we'll see.
10 more minutes.
I'm sorry to the one person in the audience.
I mean, it was.
We're gonna have,
It doesn't-
not a lot of people are over here, so we're just gonna
it doesn't-
wait a bit.
It's not very
If no one else, we'll give you a great show.
All kinds of crap, yeah. Part of it is the wheel configuration, and just the two-wheel drive has been a mess. Yeah. But, and the big weight hanging out on the front here.
Oh, start in 10 minutes when you have a figure out here.
Okay. I'll make sure that's not. Yeah, we can start talking about the first part.
Yeah.
Another bubble over there. At the same time, that's good.
Oh, okay.
It's actually pretty cool. It's actually pretty good.
I remember maybe
That's a big one. Yeah, these ones are a lot smoother. These ones need the, what's it called, the flexibility with more package.
Oh, I know what
Those ones, they actually have a like.
Yeah, like this one?
Yeah.
It's probably because you shared the hack.
Oh,
So you have hack.
Well, I was thinking when we flex seal in the future, we might need to run some first.
Hi, welcome.
Maybe.
Maybe
like
Kind of ant?
some,
Yeah.
sandpaper, right? And it's like fill out circumference of that field. Yeah, that was real.
Anyways, I don't think Brian would like a sandpaper in the water.
Get in. But we get that grip though. We get that grip though.
People are like, I could go down there and meet people. Or I could sit sitting and watch it.
that's like,
Yeah.
so like
I guess, but like.
trying to like,
And we just
Come
kind
on.
of preach to an empty room. Yeah.
To be honest, I'm probably just
Okay, I'm gonna turn it off.
I'm just gonna talk about
YouTube.
You don't want to miss this opportunity.
Okay, hello. All right, let's get this stream started. Welcome everyone to our little seminar for Crimson Robotics. My name is Christopher Tran. I am the president and team captain, and we're the combat robotics team at OU. And today we're gonna give a short presentation. Well, a presentation on who we are, what combat robotics is, and in the middle of it, we'll just show off some robots and talk about our stories here in this club. So let's go. So to start us, and so here's our little itinerary for this presentation. It's just basically going over what I just said. And if you have any questions, save it till the end. We'll have a few minutes to answer any questions that you might have. So we're going to start off with Brian to introduce who we are.
All right. Hello, everyone. My bad. All right. Hello, everyone. We're Crimson Robotics. We're a BattleBots team at the University of Oklahoma. We were established back in February 2020, so we're just 2 years shy of being a club. And our mission here is to make robotics more accessible to students and as well as the general public. And we want to make robots fun and more welcoming to the community. So we like to build robots. And what's more fun than destroying other robots with our robots? So to destroy other robots, we go to these local competitions, like in Tulsa, where we had a croc competition, which was a combat robotics of Oklahoma. They run a lot of combat robotics tournaments around the Oklahoma area, and it's pretty fun. We've also been looking into doing competitions around the United States. So, for example, there's a competition in Dallas sometime next month, as well as there's a competition in Connecticut called Norwalk Havoc, which we plan to go as well. Ultimate goal, though, is to get our team on international television. If you've heard of the show called BattleBots, it streams on the Discovery Channel. And basically, we want to make a 250-pound robot to participate in the tournament, which is awesome. We would like to go, but we need to learn and build our robots to be better and stronger and more awesomer. But we're still having fun, which is awesome. Okay. This is from our recent competition in the Science Museum in Oklahoma. We brought our 1 pound. We brought 2 ant weights and our 1 beetle weight. And it was nice, yeah. So, and we won a couple bouts and lost a couple bouts, but we had a lot of fun, so it's pretty cool. All right, next.
I can take over from here. All right, so what the heck is combat robotics? Well, combat robotics is basically a sport where 2 robots fight to the death. It's in the title, so I mean, do with that bit of information what you will. If I were to compare combat robotics to any other sport, I would compare it to boxing and F1 racing, where in this sport we have 3-minute bouts where the goal ultimately is to destroy other robots and make sure that they're incapacitated and just not moving. And while we're still moving in the end. And after each fight, we would go back into the pits, repair our robots, and be ready for the next fight. And at these tournaments, after each fight, sometimes fights can get really, really rough to the point where we have to do a whole tear down and rebuild of our robots. And we do have a time limit for how long we can repair. It just depends on how the tournament goes, how fast each matches go. Some matches go the full 3 minutes, other matches just done in a second. But generally, we're guaranteed a minimum of 20 minutes per fight. And as you keep going up on the higher weight classes, it gets very difficult. And speaking of weight classes, that was a good time to introduce some robots that you might see in combat robotics. So robots in this sport can come in many different shapes, sizes, weight classes, and different weapon types. Where's the laser pointer? Right here. Okay, cool. So as you can see, I'm just going to use the pointer. On the right here, we have an example of an ant weight, which is a 1 pound robot this is what you would normally see at smaller competitions and what people would start off with if they're getting into the sport. You know, you could just buy one of those and just go straight into battle. And then right here in the middle is an example of what's called a beetle weight, which is a 3-pound robot. This is actually our beetle weight, Unga Bunga, as I like to call, but we're going to get into that in a little bit. And then right here is an example of a 250-pound robot. And like what Brian said, you would see robots fight on the TV show. That's actually the weight class of what you would see on TV. It looks really small, due to like the positioning of the cameras. It has to be far away from the action. But if you look at one of these up close, it's massive, and the hits are much bigger. And that's what we're hoping to achieve later on. Now I know it's like a big jump in between like 1 pound to 250 pounds, but there are some more weight classes in between, such as like a featherweight, which is 30 pounds. But I just wanted to show these off because these are the most popular or well-known weight classes right now. And here in this slide, here's some more examples of 250-pound robots you would see on TV. These robots come from a TV show in China called King of Bots, or This Is Fighting Robots. I don't know, like their name changing is kind of weird. You can find it on YouTube if you're interested. But as you can see, like all these robots are vastly different from each other. Builders have come up with like different ways to go into an arena and fight robots with different weapons. You would see like some saw blades, some pneumatic crushers that can crush at about like 10 tons, I believe. I think that's what this can crush. Some axes, some robots that launch other robots up into the ceiling, or if you want, you can have your whole robot as a weapon and basically create a Beyblade right here. And so, let's see, what was I about to say? But yeah, there's a lot of variety. And the great thing about combat robotics is that there's really no limit to what you can build. The only limit is weight, and as long as your robot does not have a projectile or liquid weapons, entanglement weapons, just some minor rules just for safety reasons and to keep the fights more exciting. But yeah, no, it's a very open and expressive sport, which is why I love combat robotics. And I'm going to show you a few fights that we've done in the past. So in the next 3 clips you're seeing on your screen, these are from a competition called Croc at Tulsa Maker Fair. This occurred back in August 18th or August 8th, somewhere around there. And this is actually our first outing of our 3-pound robot. So we're just going to go ahead and play these videos.
Let's get both bots upside down. Kickback trying his best. He got himself flipped over. Unga Bunga still upside down. He's got that handlebar spinning though. Really flew him across the arena. Unga Bunga's still moving though. He's got this handlebar spinning a little bit. Kickback taking advantage of a little delay there. Taking out the aggression on the wall of the arena. Looks like the weapon on Unga Bunga is not working here.
Yeah. Well, actually, my teammate Jesse was piloting most of these matches.
Yeah, robot was upside down during most of this, so your controls get inverted.
Really well. Kickback weapon first. There you go. There you go. It's back up and going. Both robots still grinding on him. There goes the tire. And tapped out.
And then Jesse tapped out at the end. That was one match where we sort of held our own against. There were some really fearsome robots at that competition. And in the next match, you'll see like one of the best that we had to fight against. So this is our robot Unga Bunga versus currently, I think, one of the best robots in this competing in this in the States. Actually, it's ranked number 10 world, like nationwide. So this is Unga Bunga versus Ablation.
2, 1, fight. Both robots up to speed and weight. Ablation with the first little bit of advantage. There's some spark. There's a bounce off the ceiling. Now we're missing a wheel. Another big hit. Unga Bunga's still moving though. Oh, there goes the belt off the weapon of Unga Bunga. He's still crab walking though, so he wants more. Ablation doing his best to get up there. match is not over till somebody taps somebody. He can't move. Another really good shot. Big hit.
Gotta give props to our teammate Jesse for just still trying to fight only with one wheel.
Oh, they did the thing.
And that's how we ended the match. We weren't able to move from that position, and we got counted out. Or I think, no, actually, I tapped out. There was no point in continuing the match anymore. But yeah, no, we had a time back at in Tulsa Maker Fair, but we've learned, and hopefully in this competition season we'll start to win like a lot more matches. And there's one more fight I want to show. This is not involving any of our robots, but we just watched this fight at the tournament, and we just loved it so much. This is someone made a robot, a wedge robot, a steel wedge, and they stuck a Thomas the Tank Engine shell on top of it and called it Thomas the Dank Engine. It was it was like sort of a semi joke bot, trying to be competitive, but it's really fun to watch. And they were up against let's see, this horizontal spinner called Rain. It was the tournament organizer's own robot, and as you can see, Rain is pretty fierce in this fight.
Put down wedge to good use. Stay focused.
It's just like so close up there.
Notice Thomas is dominating this match for most of it.
It's doing fairly well. You wouldn't think, but like they're very controlled until. Yeah, all of them are the same weight. All these are 3-pound robots. As you can see at the end, that was visceral. Now, wait a minute. What? Yeah. And actually, this one fight can be described with just one image. Hold on. Just right before disaster. There's a reason why Thomas hates wearing a snowplow. But yeah, that's some of the stuff that you would see in combat robotics. It's all fun, just fun and destruction everywhere. We love it. And now we come to that time where we do a little demonstration of our robots, and Jesse will take us through the design of our 3-pound robot.
So you guys need to.
Yes.
Yeah, totally. So right now, I'm going to walk us through a little bit about Unga Bunga's design while Chris gets us prepped for the demonstration. So us right here, this is Unga Bunga, as mentioned before. This is our first 3-pound robot, first fielded at the beginning of last semester, and fielded again once since then. First beetle weight, so we had a lot to learn from doing this one. Now, here we have a top view. For the benefit of people in the room, I'm going to use a laser pointer here, but you should be able to follow along over the stream. So this is a top view of Unga Bunga, the original 1.0 version. And you can see a lot of the important components here. Here in the very back, the white object is our battery. Up at the very front, we have a brushless in-runner weapon motor that's connected via pulley and belt to another pulley which operates our pretty formidable beater bar in the front. That weapon is the heart of Unga Bunga, and it also makes up a considerable portion of the weight of the robot. Here in the back, we have 2 brushless drive motors for our wheels, ESCs packed in the back. And here's something interesting. This is the brains of our robot on the left side here. Now, traditionally, this had been a receiver, radio controller system, very simple. So it's like a souped up RC car, essentially. Right now, what Chris is actually working on, and some others, is using an Arduino as the brains of this robot as a custom receiver that's going to be able to enact a bunch of automated moves. Chris, would you like to say anything about that?
Yeah, sure. So like Jesse mentioned, traditionally like people have been using something like this. This is a radio transmitter. It's common off-the-shelf things that you can buy at any store. The reason why many people use this is because it's just simple, it's easy to work with, and that's all the robot needs. And really, like combat robotics, despite the name, it could be seen as just souped up RC cars on steroids. But what I'm trying to do here with this Arduino project is make these robots a little bit more advanced. So I don't know if any one of you have seen the meme like teleports behind you on YouTube, where there's like two sumo robots, and then one of them just zips around behind the other robot very quickly, and then says, "Oh my, one more." And then just knocks him out. I'm trying to do that here with combat robotics, actually. In fact, this is the first implementation, I believe, so far of someone doing something like that, where we're using a pre-programmed moves in a fight. So imagine like me just like in a fight with another robot, and we're just trying to outdrive each other. And if I get the positioning correct, I can just, with the press of a button, the robot can do the move automatically for me and just get behind them. And then it's once you see it in action, it's very hard to react to, especially if you're on the receiving end of it. And
So how do you go about counting?
oh, you can't. You just have to predict about it. But the thing is that like I can do this thing where I can condition my opponent, like just keep going around them every time, right? And then make them think, oh, he's gonna do that again if if I'm at a certain distance from him. But I could pull a fast one on him and just not do it. So he'll be turning himself around while I just keep going forward.
Yeah.
I'm bringing mind games into the sport. And it brings, like, this system, I believe, will bring, like, a lot of consistency. And now this is not a replacement for good driving. You still have to practice figuring out how to outdrive someone else. But it will enhance your driving, essentially.
Yeah, it's just one more weapon in our arsenal.
Yeah.
Yeah. Other than that, this is the stock original setup for Unga Bunga. We're using it as a test robot for this new technology, and we're also planning on fielding it for fun, just to give it one last hurrah. Now, the process for making these robots, especially Unga Bunga, starts with design in CAD. You can see here a SolidWorks assembly of our structure. Now, like a lot of other engineering challenges, we actually do have a lot of design constraints. One of those is the available hardware. We obviously have to work around what sort of batteries are available, what type of motors we can use, screws, axles, basically anything that we have to buy from the store we have to account for and build the robot around those. Another big one is actually manufacturing capabilities, because those really change over time. Over the course of the club, we started out with the only resource available was a power drill and a 3D printer and a bunch of tape. And that was what we had to work with. And so that really dictated a lot of what our first robot looked like. And since then, we've gone through stages where we have ability to CNC equipment, drill presses, about anything that you might need for making a more advanced bot. And that really dictates what materials you can use and what kind of geometry you can effectively create. Materials is also a really big driving factor. A lot of bots utilize, there's countless materials that you can use depending on what sort of robot you're trying to make. Many use very dense hard metals, and they'll make very small, dense, survivable robots that are very speedy, very compact. And a lot of that requires you to specially choose very compact, expensive motors and things like that. We have gone for a nearly all plastic design. This allows us to use a lot of easy to get stock materials, such as high density polyethylene sheet, which we use for most of the chassis. We can use 3D printed parts, such as these standoffs right here, acrylic panels, which you can't see in this image, for the top and bottom. And again, that's going to dictate what geometries we can create and how we want to attach the bot together. And this actually plays back into manufacturing capabilities, because if you are, like we are, stuck with using a CNC router to make your body panels, and you can find mostly sheets, that's going to mean that, okay, we're not going to make a unibody design, one big chunk of high density polyethylene that we then cut out on a mill from a giant chunk. We're going to actually build it out of lots of smaller panels. Weight is a huge constraint. We actually have not had big problems with that, because being made out of plastic, Unga Bunga is both fairly strong and very light. We've been underweight every iteration. This is actually going to change, because our most recent developing bot, we're going to need to use a lot of weight optimization techniques, lightning holes, special considerations for materials, for internal components and standoffs, just because that gets important once you start getting close to that 3-pound limit. And then, of course, performance. It doesn't matter if you have a light bot that's easy to make and it breaks down all the time, or it's not fast, it's not controllable, it's not powerful. That's one of our biggest considerations. So the primary design driver, what we had to design the robot around, is, of course, the weapon. That is the heart of Unga Bunga, is that massive beater bar on the front there. So it's designed around a giant chunk of aluminum that was milled out to create this part right here. And that's our finished weapon. Now, the chassis, as I said before, mostly constructed from flat HDPE sheet. Now, the convenient thing about this is it's essentially cutting board material, which, as you know, cutting boards are resistant to being cut, which is very useful when you're fighting bladed robots. And also, it's literally everywhere. So as long as you take into account the thickness of a cutting board before you design the robot, you can just go to the grocery store, buy a cutting board, and make a robot out of it. It's pretty awesome. A lot of the body was made by machining and 3D printing. So the HDPE was what we machined. And then for less essential components that needed a little bit more complexity in their shape, we can use 3D printed materials such as TPU, PLA, ABS, pretty much whatever we want. And then here we have the most recent design of Unga Bunga, obviously unfinished so far. We're still constructing that right now. As you can see, there's a lot of design changes. There's now a pulley guard over the front motor. There's beefed up wheel guards, and we have new motors inside. These are brushless drive motors rather than brush drive motors. And this is a good example of the whole how we operate as a team, is that it is design iteration after design iteration. You know, the design evolves constantly. I think the closest thing that I could compare it to would be debugging, because you'll create a robot. You don't necessarily know how it's going to perform because the environment that we're sending it into is so dynamic. You can't necessarily model all of the different impacts that it's going to be under, you know, what surviving 8 matches is going to do to your internal components. You really just don't know until you do it. And once you do it, you'll go back to the drawing board, you'll repair what broke, you'll make design changes, and then you'll find other things that break further down the line because of what you fixed. So say you fix the problem that we had in our first fights of our wheels flying off all the time. Okay, well, now those loads are more easily transferred into our motors and our gearboxes shatter. So each iteration, you find new problems, and that's really how we operate. We don't have all the answers when we first design it. We can't predict everything. So it's really just trial and error in making smart design choices after every failure that we eventually get to a successful spot.
I'd also like to add that this is what makes combat robotics a lot more different than any other forms of robotics, such as Mercury, IDBC, or any other task-oriented kind of competitions. Usually you'd be assigned the tasks, and then you build a robot to solve that problem, and then usually that's it for the year for those kind of competitions. Whereas we really heavily focus on the iteration, and we believe that true innovation can come from finally fine-tuning a design to eventually hopefully we'll get something that's unbeatable. It's possible, but it will take a long time to get there. And that's the fun of combat robotics. It's just finding a problem, solving it. And now is the time for the demo. Okay, and now comes the time we've all been waiting for. We're gonna demonstrate Unga Bunga in this box. So as you can see, we have some materials that this robot's gonna really hit, a piece of cutting board, and some lost some matches before. Why the heck are we doing this to begin with? Yeah.
Like I said, I'm going to be talking about why we do what we do. Well, it's fun. Funny thing is, watching two robots fight each other is actually a pretty good time. Um, and lost my words. A really good thing about BattleBots is that it's a really good entry point into robotics. I mean, anybody can do it. Our members range from soon to be graduating seniors to freshmen, college of engineering, not college of engineering. It's a variety of majors. It's it's introductory level, but it's also incredibly engaging. Um, and as we've discussed before, previous slides, the design process is fluid, it's iterative, and it is a great conduit for creative expression. Um, as long as you're, weight class within the allowed weapons, you can really do whatever you want with your bot. It's the community here with Crimson Robotics is also very, very tight knit. We're all pretty close. We're always welcome the new members, and designing your own robot gets you really good hands-on experience. When you're designing your own bot, you are in it from the design stage to manufacturing to testing and eventually probably competing, which it's always a good time. I think part of our goal is to show that our ability to compete in BattleBots with our group, we can compete with other big name and large universities that have BattleBots groups. Yeah. I mean, honestly, who doesn't like seeing robots get destroyed? It's a good time. It's fun. There's flames sometimes. So I'll hand it off to got some stories.
Yes, so we get to the part where we get to share some of our experiences that in this club over the years, like whatever like some little funny stories here and there from competitions that we went to, or I'm gonna start out with hold on. Actually, I should just go to the stand. I'm gonna start out with. Oh wait, actually, no, I'm not gonna start out with apparently.
I'll start out.
Yeah.
All right, for my story, I'll harken back to our Tinkerfest competition at Science Museum a couple months back, where we had a competition with a bunch of others. It was both it involved both ant weights and beetle weights. And we put in our beetle weight and our new members put in their own ant weights, and so it was nice to see that our freshman members were able to compete so early. Um, so just like how Jesse and Chris alluded to earlier, it's not just about practicing and engineering and iterating through designs and stuff. We also work. We also work and deal with in the field problem solving. So, for example, this is Jashawn's robot. It's called Breakfast at Tiffany's, and basically right before competition, right before one of his battles, he had trouble getting the wheel motors to stay in place. So I said, you know what? Let's just drill holes into the bottom of this robot and get zip ties for my car to make the motors stay in place. And we did get it to stay in place, as you can see. it's it's very beautiful. It looks like he's gotten it.
Having a body and printing it in 2 days isn't a good idea.
Yeah.
So yeah, I faked them on initially. That was not a good idea. And so we went through and drilling through it. And so I got
Yeah. So like it's not just yeah. So like we do a lot of last minute engineering, but if it works, it works. You know, the engineers there's a problem solving ethics. Anyways, we bring of course we should have been a lot more prepared for something that could happen like this, but it's again it's an iterative process. So a lot more problem solving and a lot more getting ready for next competitions. So we learned a lot about this competition. Yeah, it was pretty fun. All right, and then Chris.
So, so I have about actually the beginnings of this club. So this harkens back to like fall of 2019, which is like the beginning of my sophomore year. I wanted to start like after watching the television show BattleBots, I was inspired to try to start a team at OU. At the time, I didn't know how to go about it, so I just kind of like went competed unofficially for a bit. But this was the first competition I went to. This was a Tinkerfest at the Science Museum. It was an event where like people can come out, just build stuff for free. It's held by the Science Museum around like end of September, early October. So like just heads up if anyone's interested for more robot combat in the next few years. But yeah, as you can see, it's like just me as a young lad right here with Jesse. We were like 2 out of like 3 people that went over there, and we competed in the 1-pound weight class. And so speaking of which, here was our very first robot. I called this thing Power Rage, and yes, oh look at its eyes. But so this robot was like I said, 1 pound. It was made of okay. Well, actually, I shouldn't say 1 pound because at the like at the time, like I planned this out a little bit last minute, and some things didn't work out too well. So it was actually like half a pound, not quite 1 pound, but like we're still within the weight limit to be considered part of the ant weight class. So we just rolled with it. I designed this like very crudely in CAD, 3D printed it out in PLA. This, by the way, this whole front wedge is actually 3D print, like fully 3D printed in PLA, 100% infill. So it's just solid plastic. Try to make it as durable as possible. The mindset behind this robot was to try to deflect hits and just make the opponent's like weapon hits, go back into their own robot. Like with combat robotics, you see like powerful like spinning weapons just like knocking opponents up in the air, but and doing a lot of damage. But however, with like one of Newton's laws of physics, like there's like whatever happens, like one reaction, there's an equal opposite reaction. So whenever like you see those big hits do transfer back into like your own robot. And so with this robot, like I was hoping to deflect these hits, control the match, and make sure that my opponent breaks their own weapon that way. And with plastic, it's going to be a tall order, but yeah, no, that I was hoping that it would work. There were so many things that I've learned when building this robot. Like that's how you normally learn through like design process of every time you build a robot. It's just like early mistakes that I found out and try to improve upon. For example, getting this robot was done like the night before the event. It's kind of common theme like early on when you start building your first robot that you build it at the last second, which you shouldn't do. Otherwise, like a lot of things go wrong.
You always think like you just had it, design it, just like slap it together.
Yeah.
It's not bad.
Just throw it in the arena to see what happens, which is sometimes the mindset of like combat robotics, but and we could have done better. But like there's some other things like it didn't occur to my mind that we needed gearboxes for torque. So these wheels were directly driven onto our motors, and we barely could move at all. Luckily, someone at the competition was gracious enough to lend us some like more powerful, like higher torque motors, but we were just so slow. It was just like crawling across the floor. That's basically what it was. But
Basically, anytime you see duct tape on a robot, you should be concerned.
I'll get to the whole duct tape thing. That's a bit in of itself in the next slide, actually. So this was before we had our fights. This was after. So yeah, no, we were facing off against another like spinner type weapon blade, and they, as you can see, they chewed up a lot of the plastic and sliced through the tape. By the way, the underneath that tape was our circuitry. One more, if they cut in a little bit deeper, we could have been done.
Yeah, our battery was laying just under that duct tape.
Yeah. Oh no, it could have been a real disaster, and we never brought spares of electronics, so yeah, that was a thing. That was
also like protect fire.
yeah.
But you know
Luckily,
what?
that-
The shield's still there. Wedge is still there.
We still have the shield actually as like a little memorial piece, but yeah, no, it's crazy. And what happened during the fight? I wish I put on the footage, but I couldn't find it. It's been lost to time. What happened was like our opponent just struck us at one of the wheels, and the wheels were 3D printed as well. So when they struck the wheel, the plastic bits kind of like ran into our own little shield and just caused us not to be able to move anymore. And so we were counted out, and that was the end result. Overall, like despite us getting like destroyed, we learned a lot and we had fun, and that drove us to today where we're just still fighting, trying to get those wins. But yeah, that's the story that I wanted to share. There's another story. So Jesse.
Yeah. So this is back during the Maker Faire in Tulsa. Like I said before, this was our first time fielding Unga Bunga, first time with a 3-pound, and this is really one of the first robots that I had a lot of help manufacturing and designing and testing it and things like that. And I ended up driving in a lot of the matches. And I definitely learned a lot, like just how often you get flipped upside down. Like I thought, oh yeah, if I learn how to drive normally, that should be good enough. And then you end up upside down every match. And I'm like, okay, now all of my controls are inverted. I really should have practiced driving upside down a little bit more before coming here. And we learned so many things about that were wrong with this design, because this was the 1.0 version. The wheels came off all the time. Our drive belts didn't work, so we had to take a piece of rubber tubing, cut it in half, fit it, use a soldering iron to melt the ends and stick it together. And you know what? That drive belt had 3 pulleys, and the robot 3 times shot out from underneath of it in matches and is still in one piece to this day. No idea how that happened. It's still alive. But yeah, I mean, it was a crazy experience because we're going from the 1-pound to the 3-pound was insane. The level of build quality and power of these other robots, it was absolutely insane fighting them. But we learned a lot. We learned, okay, well, this component is trash. We cannot use this because it's just going to rip apart. These wheels are going to pop right off. We need wheel guards. And so we fixed a lot. And our second fight after that at the Science Museum, probably only a month later, we survived a lot more direct hits that we would not have at this first fight. So it was definitely a learning experience, and it influenced a lot of the designs that are now going into the revamped version of Unga Bunga today.
By the way, that was Jesse's reaction when Unga Bunga was tossed up in the air.
Yeah, those were sad times. Yeah, and then that's just getting Unga Bunga ready for the fight. And you can see, oh yeah, and you can also see we use little clamps just to keep the weapon from moving before the match, and you can see the extremely janky rubber tubing. Do not run circular rubber tubing on a pulley that was meant for toothed belts. You don't get good engagement, and your weapon will not spin up to max speed because it's going to start slipping and burning, and other bad things happen. Don't do that.
So I'm going to go over what's next for this club moving forward. And so we're still going to keep on fighting. In fact, there's going to be an upcoming tournament that we're going to compete at, which I'll get to in a bit. But we're also looking to, like I said, get on the international television show BattleBots. I want to represent the school on live TV. And this year, we're trying to go to a competition called Norwalk Havoc Robot League, or NHRL. This is another premier fighting league for combat robotics, specifically on the lower weight scale. And in fact, some of the people from BattleBots with their 250 pounds, they actually compete with their own like lower like weight class beetle weights primarily in Norwalk Havoc, and we're hoping to get over there and try to fight the best of the best. I believe that it will be good experience for us moving forward, so that we know how to handle some of the best engineering in the country. And so I'm going to show you a couple of like videos, one from Norwalk Havoc and another from BattleBots, just to give you an idea of what kind of caliber we'll be facing in the future.
All right, Voxel versus Polywog. We're going with some classic Norwalk Havoc action right here.
Fight, robots, fight.
Two of the most successful bots to ever enter this competition. Both of them made it all the way to the finals last time around.
Well, these are
Polywog was
3-pound
able to pull out
robots.
the win.
Now, if you're sitting in the audience and you like Voxel's performance, go out right after this fight, buy a t-shirt from the merch table. Oh, there's a reason there's merch. Whoa, now that looked like that was a chunk of metal. Was that off of the drum of Voxel? It is! What? Polywog cut right through that drum! Wow!
Okay. Well, that's not supposed.
And for perspective, that that weapon bar, that's made out of S7 tool steel, like, or it's a harder version of like steel that you would find on rifle range targets actually. So if you, the fact that the other robot was able to cut through that says a lot. Even in this weight scale, even though they're small, they're deadly. And that's the. And so.
All right.
Now, and here's an example from the television show BattleBots with the 250-pound weight class. I want you to keep that in mind as you see these robots fly through the air and whatever happens in the arena.
Let the bot battle begin. Oh, man. Wow. Uppercut kind of whiffed on that one. Here comes free shipping, getting underneath uppercut. And now lets him off the hook. Yeah, that's exactly what I'm trying to do. What a shot by uppercut. Oh! Are you kidding? Wow. I think I got the heat off of that one. Unbelievable. Look at the wedges. Look at the front wedges of free shipping. What did you say about the front wedges? Oh, my goodness. Chin is on the side. Gary, you're on the wrong side of the road. Oh my gosh, can he get back over? He's lost the tire. He's trying to get back onto the playing surface. Oh my goodness. Wow. The countdown is going on. Gary Chin cannot get off the rails. 3, 2, 1, let's go. What a devastating ball. That is a knockout by uppercut.
So I'm just gonna go through some replays of like the explosion. It's glorious.
Oh man, hopefully you were wearing
So
your
for perspective,
sunglasses
that other
to
robot
this
had a
event. Yeah, that was
flamethrower,
just
and
ridiculous. I think
the
I
robot
felt the heat off of
uppercut
that one.
actually attacked
Just
their
a
fuel line. And
ridiculous
so
shot
that's what led to
there
that
by
explosion.
uppercut. Forget about feeling the heat. I think he got a tan during that match.
We may need to alert the fire department the next time Uppercut steps into the box. That was the biggest explosion I've ever seen here at BattleBots.
Uppercut just dismantling free shipping from that point on. Absolute mayhem here to start the night. Wow.
And yeah, that's BattleBots. That's what we'll be facing. Funny thing to note is that in those two fights, those robots were made by people from WPI and MIT. Uppercut is actually made by MIT. And I don't know about you, but after seeing these fights, I want to go fight him. I really want to go fight him. Like I want to show that OU can be as good as they are. You know, I believe that in this sport, like what I like is like anyone from anywhere can become like a champion in BattleBots mods. It doesn't matter like where you come from or anything, as long as you can prove it. Like, you know, that's all that really matters. And having a good fight as well. And let's see. And now it's time for Q&A. So does anyone have any questions? Yes, Jerry. Yeah. So, well, regulations. Do you mean like in terms of? So, it depends on like what tournament you can go in. Some tournaments do have like minor rule changes compared to others, you know. But generally, you would not want you wouldn't want projectile weapons. You know, like that. Many people have asked why don't we have like a gun on our robots? It's just like one and done. That solution, boom. But that's mainly for safety reasons. Like the arenas are made of bulletproof glass. In fact, like our test boxes have bulletproof glass on it. Despite that, like, and especially on the heavyweight class, like the glass is about an inch thick. I still wouldn't want to test that. So that's why we kind of prohibit it. But however, like in other competitions, they do sort of allow projectiles either tethered like a harpoon, like so that you can reel back the projectile, or make sure that like the whatever you're shooting, there's like a speed limit as to how fast it can shoot out of whatever cannon that you're using. In fact, in BattleBots, there is one robot that pretty much has a cannon that could shoot out metal slugs. It's just very limited, and compared to like a spinning weapon that can go constantly and have higher energy, it's not as effective. So
I believe they also made a ban on entanglement weapons in
yes.
BattleBots. Yeah.
Yes, so you can't like throw like a net on another like spinner and just make it like tangled, because like that's not exciting. That it's really nice. I like people hate it when like you throw in something and the weapon stops spinning and then you just kind of win. That's kind of a boring way to go about it. And you'll find that with some of these rules, it's made to keep the fights more exciting. Really, it would defeat the spirit of combat robotics if like you went out on a cheap way. That of course goes to like EMPs, liquid weapons, or like hacking into like other people's radios. It's yeah.
My idea was thermal lance, but nobody's taken me up on it yet. Yeah, just plunge it right into the other one. It's technically not illegal, but
I don't know about just joust.
I want to do the thermal lance.
They allow flamethrowers.
What?
So they allow flamethrowers.
They allow flamethrowers, yes, in the upper weight classes. In the lower weight classes, it's kind of far and few in between. Mainly because, like, in the lower weight classes, arenas don't have like the accommodations to handle something like that. But there's some that do. You can if you want to compete at Norwalk Havoc. Make one. What? Yes. So with BattleBots, like in the past, actually, BattleBots has been like around for like 20 years or so. Like they started back in the 90s and then like went up to the early like 2000s. They kind of stopped hiatus and then they came back with ABC and here they are today. But in the past, anyone can go on a BattleBots, but that created a problem where you see a lot of robots with the same design, which is just a wedge, a steel wedge. And so that's kind of why like the viewership dwindled down, because you see the same thing every single time and it becomes boring afterwards. But BattleBots nowadays require that you have to go through an application process where you design a robot in CAD, and part of the design you have to make your robot look unique. Like if you were to like shadow out your robot, you have to be able to distinguish it from the other robots and just look at it and be like, I know what this robot is. This robot's name, Witch Doctor or something like that. And another thing, like make it look like a toy that a kid would want to play with. That's part of the design. And like I showed you in the with some of the earlier heavyweights, their designs are so striking. That's how they get in.
Yeah, and a lot of them, like you'll see two very similar robots where like their weapons are similar and their layout is similar, but the execution and how they fit together and the little tricks that let them go faster, one's more maneuverable, one has more energy, their weapon is what makes them stand out. And then like visually they're striking. But BattleBots definitely, as far as the amount of time a day that they give them, definitely a lot of preference towards people that come up with brand new designs. So when you see something really interesting come onto the box, everybody goes crazy. There's one called Mammoth that's fairly new. Absolutely massive robot. They said, we're going to lighten up and strip down everything, make it basically like the chassis of a bicycle, and just absolutely massive with huge, very lightweight weapon. Everybody seems to love it so far, just because a lot of people don't really know how to handle it. it's once they get into this tunnel vision of these are the kinds of bots I need to prepare for, this is the kind of fights that we're going to be having, then once something crazy comes in, a lot of times they can exploit people's tunnel vision for a while, because that's kind of all that they can handle. They've been trying to beat a certain type of bot for so long that they can exploit that.
In a way, with BattleBots like forcing you to be more creative in your designs, you see more like different varieties of like how you can kill your opponent, basically. More ways of destruction, and like he says, just changing the meta. We're hoping that with our new version of our Beetle Weight, we're testing out like the semi-autonomous drive, and hopefully that will make us stand out, because again, that's never been done before. So not only in the design, but also like you said, the way it functions, and yeah, I think that once they see like how we are able to create more dynamic battles, or like battles that end quicker, or like very briefly, they might just take us in. But hey, that will be for the future. But are there any other questions?
I do have another question.
Yes.
So are there other leagues or divisions in BattleBots that encompasses, I don't know, like drones or something like that?
At one point, in early like 2015, 2016, when BattleBots was on ABC, now they're on the Discovery Channel, but they used to allow, or well, they still allowed drones as like mini bots to assist. Some of these drones are equipped with flamethrowers on the bottom, right, to shoot out flames on top. It looks kind of sick for like the camera, but those have kind of like died out, not because like they haven't allowed them back, but they haven't been really useful in a way.
They're very fragile. I mean, the solution that one person thought up was they literally just duct taped a rake to the end of their flipper arm and just swatted it out of the sky, and that was it. So their usefulness in BattleBots is kind of limited, because you really need a durable bot, and aircraft, they really don't fit that bill at all.
Also, like the drone counts towards the weight limit, and that's kind of a useless way to spend your weight, is just like have something that's basically ineffective. So why not put that weight back into your bot to make it even more effective? Like, put more weight back into your weapon or armor. Just.
So what are some examples of people kind of like thinking outside the box a little bit? What they can
do with their design?
Yeah.
Rust. Well, like, yeah, we can talk about Rusty. Would you want to describe Rusty?
Yeah.
I wish I could briefly go out and just pull up pictures of Rusty.
Well, it's he was a bot designed by one guy by himself. He's competing in BattleBots, and I think, I don't know.
Yeah.
Robust is a good way to describe it.
This is it.
He's got
the thing looks like a tank.
Yeah. It's got treads like a tank. And notice, you see a lot of bots drive around, their motion's pretty smooth. Immediately just starts rumbling when he drives. And he's got a single spike that just lifts up and drops. But it's pretty quickly become a fan favorite.
Yeah. No, with how adorable it is, you don't have to be like super competitive to win the hearts of fans. We just love to see the creativity.
Yeah, and a lot of it too is like.
Don't even get me started with some of the memes you would see in BattleBots. It's really cool.
Yeah,
this community is fun.
And something a lot of people like about Rusty is he kind of just is been thrown in the face of a lot of the really in-depth engineering that's going on in BattleBots, because I forget the exact robot, but we were it was Shatter, commenting on the absolutely gorgeously machined aluminum plates that made up the internal structure. I mean, it was a sight to behold when we got a shot of the internals of that. And then you see Rusty, which is mostly just found steel. Like, nobody makes all steel robot chassis in BattleBots anymore. But he was like, well, what if I did? Anyway, who cares?
Didn't you get Rusty from old parts on this farm?
Yeah, so the builder, by the way, Rusty was built by one person who was operating it throughout the whole competition. And he was living on a farm, and he just like happened to just cobble together some stuff he found around his farm and just put it together. This is one of the only few robots that are considered garage builds, where it's just like, no manufacturing involved. Let's get something, slap it together. But did that answer your question? Are there any other questions? Anyone would like to know more about this sport? Yes, Jesse.
What's your favorite BattleBot, Chris?
Ooh.
I
would
know
ha-
it's asking you to choose between your children, but like,
Let's. Oh man, that's kind of tough actually.
give me your favorite.
I haven't really thought about. I'm just so like such a big fan of just BattleBots as a whole. Like, there's not really.
I think
Well,
I know.
actually, well, what do you think
It's
it
got to
is?
be Shred It Bro, isn't it?
No, it's not.
It's not Shred It Bro.
It's not
Dang,
Shredded, bro.
okay.
Actually, like one robot that I can think of that's my absolute favorite of all time is Sawblade, a robot called Sawblaze.
Oh, all right.
Yeah. So basically, this was also built by someone who is a TA at MIT or like staff at MIT. But basically, the function of this robot is that it has this spinning blade and it chops over the top like a saw. But however, unlike a saw blade, it just doesn't like grind and serrate, cut through. This actually just makes a blunt like hole through your robot. And like if you see it in action, I could just pull up some videos. You just see it just control other robots, and once it pins them up into the wall, spins up their weapon, drops it down on their head.
It's
Yeah.
terrifying, like especially if they have a flat top plate, punctures right through. You'll hit a battery and then it's just over.
But there's another robot that like another one that comes close to my heart that like you all just saw earlier actually is a robot called Quantum. But this is the pneumatic crusher, and as you can see, it's just why I love this thing is just it's beautiful, and it's also as deadly as it is just beautiful. Like one time it just took another robot, punctured through, hit their battery, and then the other robot caught on fire. And it's one of the few times that a crusher actually does well in competition. And I just love to see it move around so majestically.
Isn't Quantum a pneumatic crusher? So you
Yes,
use
it's a pneumatic crusher. Wait, pneumatic crusher? No, hydraulic crusher.
hydraulic.
Sorry.
All right. In BattleBots, you don't necessarily have to have like sharp weapons to win. You can also win by like aggressiveness and like creativity and like protecting yourself. For example, there's like there's this robot called Duck, and all it does is it just spins around. this thing it's very funny, but it's also cool. So there you go. Yeah, it
Look
looks
at
like
this.
a duck too. So that's pretty nice. Like harkening it back to before. You're also rewarded for your ingenuity and like using the constraints of and rules to your advantage. Like for example, you can use multiple bots as your total bot. For example, like Witch Doctor. Witch Doctor usually uses 2 battle bots in each of the matches.
There's another robot called Gemini, which is just basically 2 spinners that acts as one team.
Yeah.
So you can go into this is the archetype known as a cluster bot, which is multiple robots that go in the arena as one. Now you might be thinking that's kind of like a little bit unfair to have more than one robot. Well, these robots actually individually they weigh like 125 pounds each. So both of them are still under the weight limit. Like combined, they create a 250 pound. And so like lowering that weight can cause some issues where like, you couldn't have as powerful of a weapon as a full 250 pound really. And if one of them like is done, then, yeah, you can still use the other one, but they're easy to knock into the air and do some damage on. Yeah, like I've seen 6 pieces actually. Hold on. Smeet. So no, not really. Smeet. That's hold on. That's one robot.
And occasionally you'll have, sometimes somebody will say, "Oh, I have 5 pounds left in my weight allotment, so I'm going to add a mini bot in just for fun."
This robot is 14 feet wide. That's. So this is based off like one of their beetle weights that is like 3 feet long, but this one is upscaled to like 14 feet wide. And you would think that it would just drive very weird, but like it sort of works. Like bots have a hard time getting around it, and their defense is pretty good, all things considered. And this version of SME now has a feature of like being able to just wrap itself around other people and has like little spinning discs on the underside at each end to like come in and just take a bite of their opponent they wrap around.
Yeah, and multi-bots do occasionally see success. Sometimes, like I said, you'll just add a little mini bot just for fun because you have the weight for it. But other times, there was recently a 3-pound beetle weight that was put into the match, and it was sturdy and fast and extremely powerful. It was able to jam itself underneath the other bot and get it off the ground. So it was completely helpless while the main robots were trying to attack it. And that didn't last, but it was spectacular use of just this tiny unassuming bot to help them get an advantage over their opponent, which you don't see terribly often.
That's one. I could show off. Should I show off the match?
It was right at the beginning of the match. Yeah.
Okay, I can look it up. But while I do, is there any questions from chat? No one's in the chat. Okay. Okay. Let's see if I can pull it. What was that video? What was that match? It was Jaeger versus this P1. Okay, I don't know if they. Well, I'll just show. We want to look it up. Anyone else have any questions about BattleBots? No? Come on. Where's the... What? Refresh. Where is the search bar?
It's just
it was there. What is this?
There, I swear.
Hold on. I'll go the roundabout way of finding it. We'll get there eventually.
There's a search bar in the top right now.
In the top. Oh, now it appears. Okay. It's fine. I'm already here. Here. It was P1 versus Jaeger. I don't know if they.
Control F to search for.
Hold on. P1 versus Jaeger. Oh, they haven't uploaded it yet.
Bummer.
Okay. It would have been very nice to see, but oh well. Pain Train versus Deep Six. Anyone else want to watch one more match before we can move on to the next section? Just wanted to show this fight, like the ridiculousness that's present in this. So we have this one robot called Deep Six that's just basically weapon. That's it.
Trying to get out of his own square. Oh boy. Can't wait for the first shot.
The weapon is 80 pounds.
Weapon on weapon.
Oh, Deep Six just made itself
It's
vulnerable
just
there
like
on the
one
flank.
of
Let's see
these
if
robots
Painter
that's
able to
just
take
a crazy
advantage of it.
design. It's just like, what would happen if we threw it in there? And we
Issue
arena.
trying to get in the right position. Oh, look at that. That 80-pound weapon. Oh, Deep Six ends up taking a chunk out of the floor again.
Big impact there, but Pain Train took some damage to that right wheel, Chris. And with their two-wheel configuration, that's going to be a problem.
Well, it can't get around still. The question is, can it figure out which direction to go? And uh-oh, we got some more rubber on the floor. This is a real problem now, Kenny.
Yeah, and it's lost contact with the floor on that right side. That's not good.
Oh, no.
Hey, there's a fire.
They'll pop off, and there it goes.
They say there's nothing like an open flame, Kenny. Just makes the bot taste so crispy and delicious. 3, 2, 1, that's a knockout!
And yep, that was Deep Six and Pain versus Pain Train in that match. So I guess there isn't any other questions. We can move on to the last thing that I wanted to show, which is before everyone leaves here, I have a couple of exciting announcements. So earlier I mentioned that we will be having a tournament will be competing in a tournament soon, and actually that tournament is going to be here at OU. So on February 26th from 9 a.m. to 5 p.m., which is a Saturday, we'll be having a combat robotics competition called Crimson Carnage in the Will Rogers room. That's the food court area in the Union. And so come on down to watch some 1-pound robots fight. You'll get to see us run our 2 Ungabungas over there, and there'll be some food. Just come on down and watch robots just destroy each other and see who's the best robot in the state. There will be more robots coming in from all around the state, and some from Texas. So yeah, please do join us. And then another thing that I want to announce is on that same day we'll be having a benefit night at Pinkberry. So this is from 2 to 8 p.m. So during the tournament, if you're hankering for some ice cream, go on down to Pinkberry and just mention Crimson Robotics. Some of the proceeds will be like from Pinkberry will go to us so that we can raise money for more robots and competitions that we'll be going to in the future. And you can follow us on social media if you want to learn more about these events. Here is we have a TikTok, we have Twitter and Instagram. If you want to take a picture or a screenshot to save all this, we're on follow us at OU_Crimson Robotics on both on all these platforms. And then if you want to email us or just for business purposes, you can email us at OU.crimsonrobotics@gmail.com. And that's pretty much it. That's the end of this seminar. Thank you all so much for attending. Okay. Now,